by SMAS Worksafe, we had an overview of UKATA and the various types of training that they had available and an overview. The second webinar, which we hosted, was widely attended, and it covered duty to manage and where the responsibility lays when managing asbestos in buildings. Today we look at the interesting topic of asbestos in soils and made ground. Historically, the widespread use of asbestos, poor waste management and demolition practice has resulted in asbestos-containing material being present in soil or made ground at many brownfield and, in some cases, greenfield sites. Today on our panel, we have Marcus, who is our technical director. I see he's not up in presenter, so I will search for him in the attendees list and push him up. Marcus is here to answer any questions that you may have health and safety related after the presentation. He is responsible for our preferred supplier compliance in areas to include health and safety, quality and environmental. He also manages our in-house team of assessors to ensure that we consistently meet our obligations to the SSIP. Professor Roger Willey is an eminent academic and successful businessman who's highly respected throughout the health and safety asbestos industry. Even though his training, research and consultancy work is in great demand both nationally and internationally, he still gives of his time freely to speak at high-profile events on behalf of UKATA. Roger has been involved as a UKATA director for many years, and his clear-thinking approach to board discussions is highly respected by all. He is known affectionately as the wise owl on the board of directors, a term which befits him well. Should you have any questions that you would like to put to our presenter or panel member, please present them on the chat, and then we will run through them at the end of presentation. I will now hand you over to our presenter, Professor Roger Willey.
Thank you. Okay, will this automatically come up in full screen?
Yes, you can just go ahead now.
Okay. Okay, good afternoon, folks. I'm very, very pleased to hear so many people in the room. A little bird told me that Mavis Nye is in the room today. So good afternoon, Mavis. I do hope you're well, and I do hope your charity is flourishing. And hopefully you can get a few more contributions after today's webinar. That's me there. My name's Roger. I think it's very pretentious to have all these things behind your name, so usually I don't put it there. I am known in some circles within IOSH and within UKATA as ARGE, and that stands for All Round Good Egg. And basically, that's all you need to know. I've been doing this for rather a long time now. I founded the first asbestos test house in Scotland in 1978. It was one of the first in the whole of the United Kingdom. I was still working at the university then, and marching through the academic ranks. So I was doing consultancy work, measurement work, training, a lot of research work, and you see a little part of it just now. And I think we've probably been involved in most of the big asbestos decisions and legislation for the last 40 years, really. And on top of that, I get involved as an expert witness in legal services, and I've done about 600 cases at the moment. In terms of asbestos contracts, well over 150,000 altogether, absolutely all over the world. And at the moment, I should have been in Santiago in Chile last week and this week to escape from the snows here. But of course, there are no flights. So we're helping the Chilean government. They have no legislation at the moment, so we're helping them to set up legislation and helping them to set up the first ever asbestos test house in Chile, as indeed we did in Turkey 2 or 3 years ago, and in Japan a few years before that, and so on and so on and so on. So we've been involved in most things, particularly in contaminated land. Before I came along, there were no rules, there were no regulations, there was no guidance from the Health and Safety Executive, nothing at all. So the presentation will talk a little bit about brownfield sites, so contamination. I'll talk you through the first ever major asbestos soil project in the UK, which was 1986. I think you'll find it very interesting. I can't say any of the technical details because it's covered by the Official Secrets Act. So I'll go on to talk then about the third biggest job in the UK. We didn't do the first one, second, we did the first and the third. And I'll talk in some detail about working protocols, and I'll end up by talking about training required and how UKATA can help you to become properly trained. So that's the programme from now until about 8 o'clock tonight. We'll stop at 4 o'clock for a cup of tea, okay? Right, the brownfield sites. There's a real shortage now in the UK of virgin land greenfield sites, a real shortage, especially here in the west of Scotland. We were central to the Industrial Revolution, of course, the first industrial revolution the world had ever seen, and we had the biggest shipyards in the world. So all the greenfield sites were used up for shipyards and associated rope factories, engine factories, and so on. So if you want to build in the west of Scotland, there is no greenfield sites. There are no sites available. So you'll have to use a brownfield site. In other words, a piece of land that's been used previously. And certainly where I live and where I work, that land will be contaminated. It could be contaminated from the demolition of buildings. A lot of the shipyards, the owners, simply locked the gates on a Friday afternoon and walked away and left it for someone else to sort out. So then the local authority was left with a problem, or Scottish office left with a problem, knock the buildings down. And this, of course, was before the control of asbestos regulations and before the Environmental Protection Act and the hazardous waste regulations. So in those days, you simply knocked a building down, irrespective of what was inside. There could be waste material discarded during manufacture, and again, before these regulations, a lot of fly tipping on sites. So that's where the contamination comes from. If there's asbestos in the building when it comes down, or if it's chucked out the back of your factory, and that goes into the ground, once you break a ground, you send in your tractors, your bulldozers, of course, the stuff's going to get airborne. And that's going to be a problem for the health of your workforce on site. That can lead to, if not properly controlled, asbestos-related diseases. And do remember, this year alone, about 5,700 people will die of asbestos-related disease this year. And that is the biggest single industrial killer we have ever seen in the United Kingdom. We've never seen anything like that. And that, of course, was the purpose of Graham's talk last week, the week before, Regulation 4, duty to manage and everything else. So we have a potential problem with the health of the workforce. We'll have a real problem with the cost of the project. The cost of asbestos remediation ranges from tens of thousands to tens of millions of pounds. We had one recently which was £30 million, and that's just the cost of remediation alone. And on top of that, we have a time delay. It could be as little as 6 months, perhaps, usually 12 to 18 months. So if you buy a piece of land without an asbestos survey, first of all, you're off your head. And if you do that, you could end up spending millions of pounds more than you budgeted for, and the job could take you as long again as you budgeted for. So a real problem for us, a problem for developers in particular. The first major asbestos soil project in the UK, in the world, especially here in the UK, was here in the west of Scotland. It's expansion of a top secret nuclear submarine base. That's where our frontline submarines are. The hunter killers are there and the big missile carriers are there. One of them is always at sea, as you know, carrying nuclear missiles, and that's about 25 miles as a crow flies from where I'm sitting at the moment. It was a time back in '86, the government was moving from Trident nuclear missiles to Polaris nuclear missiles, and the missiles are nearly twice as big, and the carriers are almost twice as big as the Trident carriers. This is one just going down the Clyde, not far from where I live. You can see armed guards here, whilst the guys are up on deck, going out into the gloom and out into the Atlantic, and nobody knows where it goes. The Prime Minister, the head of the Navy, and the captain, and no one else knows where that boat is going or where it has been. To see one of these close up is amazing. That is half as long again as a football pitch. That's about 150 yards long. It is immense. The problem here, the naval base was relatively small. The cope with Tridents, couldn't cope with Polaris missile carriers, wasn't big enough. So they bought a piece of land next door, and it was an old Shipwreckers Yard. So we have the base, we have the Clyde estuary here, going out into the Atlantic, of course. So we have the naval base, we had a scrapyard next door, which had closed down. So the Navy bought it and then put in some diggers and said, oh dear, what is this white stuff that we are digging up? And we got called in, the cavalry got called in, and we analysed some samples, and sure enough, it was asbestos. So mass panic. What the hell do we do? There was no guidance from anybody. Nothing like this had been done before at all. So what do? Get rid of the asbestos. Great. How do we do it? The asbestos industry was in its first throes then, the modern industry. There were no licensed contractors, they didn't exist at this time. There was no information available from the industry, such as it was. There was no information available from the health and safety executive or anybody else. So what on earth do we do? So fortunately, I was at the university then, and I had a little bit of a reputation. I had my own research team, my own research labs, and I got on very well with the university principal, and he just let me alone to get on with things and generate money for him and research grants. So a common sense approach, of course, is to say, there's the base, that's a clean zone, that's a dirty zone. What we'll do is dig up the asbestos contaminated soil and chuck it away. Can't tell you where it went. That's covered by the Official Secrets Act. So conceptually, it's dead easy. Dead easy. You dig it out and you chuck it away. Well, you dispose of it very carefully. In this case, it was chucked away. So theoretically, easy. Dig out the contaminated material, dispose of it, certify the land is asbestos-free, job done. Easy on a piece of paper. Not so easy when you have 100,000 cubic meters of it. Not so easy because what does asbestos-free mean? The job was quite straightforward. You take a 100 mil skim, test the ground, asbestos, take a skim off it, test the ground. And techniques of analysis are so sensitive now, we always found asbestos. So now you take off another 100 mil, test the ground, we find traces of asbestos. Take off another 100 mil, test the ground, find asbestos. And you could go on forever. You could dig a hole to Australia, and you will always find tiny traces of asbestos in the ground. So after about 3 or 4 iterations of this, I said, hang on, stop. Every time we do this, it's costing about £5,000 or £6,000. So if you carry on doing this over the whole contaminated site, we've got to spend millions and millions and millions just testing soil and getting rid of it. It's preposterous because they're tiny quantities. So I said, what's important is not what's in the soil. What's important is what you breathe in, because that gets down into the lung and that's going to give you problems. So I went back to my little lab and built some test rigs and so on and so on, because no one knew what the risk was with these tiny quantities of asbestos. So to start with, a series of quite simple experiments. We built a rig. We had a 1 meter cube in here, made of perspex, and we had a little funnel in here, and we packed it with asbestos at different concentrations. We had a compressed air bottle over here, a very clever piece of electronics here. So the valve was opened for a fixed time, a fixed charge of air, fixed air pressure, everything was fixed. The only variable was the amount of asbestos in the soil. So you press a button, asbestos goes up in the air, we take an air sample, and again, controlled circumstances, no variables. So the only variable is what's in the soil. So we measured airborne concentration as a function of what's in the soil. And as you'd expect, the more asbestos in the soil, the more asbestos you have in the air. Common sense. So we establish a graph in here. And after Graham's talk last week, and I'm sure from the work you do, you will know that the site clearance indicator for asbestos work is 0.01 fibres per mil. And that's the lowest level of reliable detection of airborne asbestos fibre concentration. So that's deemed by the HSE as satisfying the asbestos regulations. So we can draw a line across here and see where this cuts in asbestos percent. So if we are working in this region up here, if you disturb the soil with a tractor or wherever, you generate airborne concentrations which are illegal. If you're working in this tiny little bit here, you will generate concentrations which are legal. Tiny, tiny concentrations which are legal. They're below 0.01. So we identified a cutoff. That was the first thing. And then we thought, well, hang on. This translates at something like 0.01% by weight of asbestos in soil. And that's the legal limit still used today. And of course, in most cases, you've got 5%, 10%, 20%. So you're way, way, way up here. So what can we do to control it? It's common knowledge that if you wet soil, then the airborne concentration drops. But nobody knew by how much. So we did the same experiment, at this time a fixed charge, a fixed percentage in here, and we added water to it, and then blew it up in the air. So now we've got fibres per mil against the percentage water in soil. And again, there's a 0.01 fibres per mil level. So if you work up here, you can disturb the soil, you'll always have airborne concentrations below 0.01. If you work in this region, you have illegal concentrations. You can't do that. So we identified a critical point up here, and it was about, from memory, about 20-25% by weight water in the soil. So we've identified a minimum percentage. We've identified, if you're above the minimum percent, we identified how much water you had to put in. And then to finish that off, we have rather a lot of contaminated water. It's a big site. And the Scottish Environment Protection Agency don't like asbestos contaminated water going into the Clyde estuary, which is tidal. The tide comes in, so the tide carries the contaminated water up to the centre of the city. The tide goes out, and you carry asbestos out in the Atlantic. And nobody likes that. So the last thing we did, we set up some experiments, and we devised a filtration mechanism in here, a large-scale mechanism, of course, for all the water. So now we completed our research work. We know how much weight percent in soil will give negligible risk. If we're above that, as we always are, then we know how much water to put in, and we know how to filter the water to minimize the risk of the environment. Pretty damn good. All that was in a lab in record time, and then we put it into practice on a commercial site, and it was very, very successful indeed. And we got the job done pretty damn quickly. The job was a complete stop for a few months, but once we started, everything went to plan, came in on a revised budget and so on. Thank you very much, said the Royal Navy. And thank you very much, said the Health and Safety Executive, because this was a model. Can't say too much more about that. But 2 years later, the Scottish Government, Scottish Development Agency as it was then, wanted to build a very, very large private hospital near to Glasgow Airport. And the only piece of land available, which was fairly close to the airport, just across the river, a short helicopter hop, that's all. The problem there's the piece of land. Hang on. That's what it looked like. Over here was an old Shipwreckers Yard. Over here was an old Victorian dock with great big stone walls. And over here, a nice flat piece of land. And combined, this was certainly large enough for a very, very large, very prestigious hospital, which is what's there now. But the problem over here, this was a Turner and Newell asbestos factory, one of the biggest in Europe. Because the biggest shipyards, you need big asbestos factories. It closed down. Turner and Newell walked away, leaving behind the structure, leaving behind hundreds of tons of asbestos. They just walked away. The local authority, Dumbarton District Council, made it safe by burying all of the asbestos materials. They dug huge holes and buried it. And that was, I said one of, I think at the time, that was the largest asbestos tip in Europe. So what we've got is a prime piece of land here, apparently a prime piece of land, relatively close to Glasgow city centre, relatively close to Glasgow airport, ideal for purposes. A motorway 5 minutes away, ideal. But we have this problem of contaminated land. The saviour was here. This was an old Victorian docks, huge stone structure here. Test boreholes were drilled over here, so we worked out total volume of asbestos contaminated soil. We did all the measurements here and the depth in here, and the volume of this was more or less the same as the volume of this. So, okay, why not dig it up? Well, build a dam, a coffer dam across here, pump all the water out, line it with geotextile membranes, dig all this up and put it in here, and then put a cap on top of it. And that was the suggestion, and indeed that is exactly what happened. We've established, as we did at Faz Lane, a dirty zone, a clean zone. So the dirty zone was fenced off in here. There's the tips, there's the coffer dam, water pumped out, geotech membranes. A haul road built across there into here. Security fence all the way around. The only way in for people is here. The only way in for vehicles is here. And here we have a clean zone outside the asbestos zone. So the concept was you put vehicles in here, you put diggers in, you put lorries in here. Once they go in, they are there for the duration of the contract. They don't come out at all. At the end of the contract, of course, then all the asbestos is in here, it's sealed, so you can then decontaminate these and bring them out at the end of the contract. Any person going in here is contaminated, they dress like spacemen, of course, and at the end of each shift, they go through a decontamination unit and come out as normal people. So the concept is, remember the key factor here, because the concentration of asbestos in the soil was pretty damn big. It was 30–40% in parts, way above our safety margin, which meant we had to wet these strips. So we work in a strip perpendicular to the river. Here, the diggers would go in, the lorry would back up. Well, first of all, we had water bowsers, which went up and down here, up and down there, to make it thoroughly wet, and we tested it. And when it was more than 25% water, okay, boys, you can dig it out. So these guys go in, dig it all out, put it in the back of the truck trundles along here, reverses, and drops it into the big hole in the ground, lined with geotech membranes. So once you've cleared a strip here, then, well, this strip here was cleared first of all, and then we have clean lorries coming from quarries and wherever with clean infill. They drive along here, drop the infill. We've got a clean bulldozer here which pushes it flat, so we fill this with clean infill material, boulders first of all, and then graded soils after that. So the dirty vehicles never come out, the clean vehicles never go in, and a strict segregation here. On top of that, we had to put a water sump in, of course, there's lots of water, and we put in a filtration system, and that went out into the River Clyde, and we had boats out here testing the water at the outfall to make sure there's no asbestos in it. We also set up airborne monitoring stations. The prevailing wind is off the Atlantic, so the prevailing wind is left to right on my diagram here. So we set up samplers upwind, and we set up samplers downwind. We didn't do that on day one. and we got badly caught out. The wind came up, and there was all sorts of plant material over here, and we're sampling downwind down here, thinking that was the right thing to do. And if a sample, we had samples on the perimeter, which is houses about 50 meters away, samples on the perimeter, samples on the driver, samples on the driver. We've got navvies with shovels going here. We have samples on these guys. And if any sample was above 0.01, lowest level we can detect, a klaxon sounded, work stopped, everything stopped. We went to investigate. So we were about a week into this, and the klaxon went. We measured a sample down here above 0.01, klaxon went, all hell broke loose, of course. We couldn't find anything wrong. Everything was done perfectly. And we found up here dandelions. You know, the things as children we used to blow, you know, big head, and you blow it and all the little veins go off. Dandelion head down a microscope is a dead ringer for chrysotile, white asbestos. You won't tell the difference between one and the other. So we got the samples. We then did some electron microscopy work on them. They were not asbestos samples at all. They were plant fibers. So from that moment on, we sampled upwind and we sampled downwind. So if you can get fibers up here and you get fibers down here, if there's more fibers here, it's coming from your site. So if you are involved in sampling, in remediation of sampling sites, you really have to sample upwind and downwind, not simply downwind. Okay, that was relatively successful. Now it looks nice and plain and simple here. In fact, of course, it's a massive building site. So here's our tractor units going in. There's one of the water bowsers. So imagine the water bowser goes up and down, up and down, up and down, makes it saturated. We measure, okay, boys, send in the diggers, send in the lorries. You get a feel for what it was like. These are the big moxies. So we've got our JCBs in here, digging the stuff out, putting a moxie. Moxie goes up the main road, over to the hole in the ground, which is over there. So pretty straightforward, apart from scale. There's one of the moxies there. So I should go back here. The drivers are all protected. When we first started, they wore big full face protectors like the asbestos removal boys did. And that was very, very dangerous indeed, because in the winter time, the sun is low in the sky and it blinds the drivers here. So there's a real risk of running over people. We took over 1,500 samples in our stay there, and none of them were above 0.01. Other than the one dandelion head. None of the others were. Now that meant we could relax things a bit and give the drivers here just P3 respirators here. Perfectly adequate to protect against asbestos, and of course they can now see and they're not going to run over people. So you get a feel for what the site was like, absolutely massive, dirty, mucky, and everything else. Trivial jobs like a puncture become a major test of resources. Normally, you have a flat tire on a car, you pull over, you phone AA, or they phone a tire company, along will come a truck, they pump up your car, take the wheel off, change the tire, and put a new one back on. Same principle here, exactly. But these two lads now are in an asbestos contaminated zone. So these guys, they're just normal tire people, come from a tire shop somewhere. So we had to train them, first of all, how to put on respirators. We had to have the respirators checked before they could go on site. We had to train them how to put on the PPE and how to take it off. And we had to train them to go through decontamination units, because they can put their gear on and walk in, but you can't do that going out. You have to decontaminate. So even a simple job like changing a tire becomes a major logistical exercise. And all jobs became major jobs on that dam site. One or two slides just to finish that off. And that's what it looked like just at the end of construction. Now all this is landscape. It looks very nice now. But there's the brand new hospital. You've got a 5-star hotel over there. All of this is landscaped. There is the old Victorian dock over here. When the last of the soil went in, it was capped with a metre of clean topsoil. Then a geotech membrane went on, belt and braces, another half metre of clean topsoil on top of that. And then we got some garden people to come along and put in shrubs with short roots which go horizontally. You don't go down and disturb the geotech membrane. They go horizontally, so everything is bound together. So that has become a very prestigious hospital in Scotland in general, and West of Scotland in particular. It was built for the private market, which collapsed. Eventually, it was sold to the Scottish government for $1. The build cost was £150 million sterling. But now a very prestigious organisation indeed. These days, we're a lot further forward now. We know how to do these jobs. My little company, we do it all the time, all over the country. We know what to do. We know how to train people, and I've been instrumental in all three of these courses. So we have an asbestos awareness course for people who may be exposed to asbestos, plumbers, and which Graham talked about last week. We have an asbestos in soils overview course. We have an asbestos non-licensable work course, which is what these boys would do on site. It's not licensed work, it's non-licensed work. So we have awareness courses, non-licensable work to allow these people to work, the awareness for the drivers and so on, the Moxie drivers, the non-licensable work course for the guys doing the digging and all that. We have an overview here for the engineers who are going to plan the job and supervise the job and everything else. So we will look after that as UKATA. The employer, of course, must do site-specific RAMs, risk assessment and method statements. And with people with no experience at all, our company will come along and help you write those things. And that was it.